Hello, everyone. Thank you for tuning into our panel on engineering and engineering careers. We are the Biomedical Engineering Graduate Student Association at UW-Madison, which is a group of biomedical engineering grad students that aims to build community in the department and also provide outreach on the benefits of an engineering degree to the community. And so we're very excited to be a part of the Wisconsin Science Festival this year. And today we have a panel of 5 biomedical engineering graduate students here at UW-Madison, and they're going to share some of their experiences of their process of getting an engineering degree and their experience so far in graduate school. So my name is Hannah. I am also a grad student here at the university, and I'll be the moderator for today. So before we begin the panel, I have a quick presentation on engineering versus science, because they're related, but there's definitely some important distinctions, as well as a brief overview of all of the different types of engineering and what each would entail. We thought this was important to include because, at least personally, I remember as a high school student not really knowing what engineering was. I had heard it as a buzzword a couple times, but I was definitely eager to learn more about it. And I think the more information we can spread to a younger age group on engineering would only create excitement and interest in this field. And so engineering is the application of knowledge in order to design, build, and maintain a product that solves a problem in our community. This is different than science, as science is the body of knowledge or the study of the physical and natural world. So in engineering, you're taking a lot of the principles that have been discovered through, hundreds of years of scientific endeavors and applying them to solve really pressing and challenging real world problems. And so the focus of engineering is that application element of it. And so now I'm going to go through all the different types of engineering and kind of give you a brief overview of what they entail. So let's start with mechanical engineering. Mechanical engineering uses engineering physics and math to design and manufacture different mechanical systems. And so this could include designing and building machines such as pumps, compressors, engines, and furnaces, and also involves robotics a lot of the time. Some courses at the undergrad level that you will take as a mechanical engineering undergrad would include thermodynamics, fluid dynamics, materials, controls, and computer-aided engineering, CAD. Next, we have electrical engineering, which is the field of engineering that involves the study and application of electricity, electronics, and electromagnetism. And so some examples of work that electrical engineers do includes mobile communications and robotics as well, data processing, and electronic sensors. And so some of the classes that you'll take as an electrical engineer undergrad would include signal processing, electrical circuits, electromagnetics, and controls. Chemical engineering involves designing equipment, systems, and processes for the chemical production of products. And so some of the big sectors in chemical engineering are pharmaceuticals, petroleum and plastics, as well as the energy sector. Some courses you would take would include reaction kinetics, lots of chemistry, obviously, thermodynamics and fluids, mass and heat transfer, and process design. Next, we have industrial engineering, which really focuses on optimizing the processes behind a lot of businesses and manufacturing. And so this would include streamlining processes and workflows, organizational management. And some of the courses that are important for industrial engineering include statistics, quality control, system design, and ergonomics. Next, we have aerospace engineering. And so aerospace engineering has 2 main facets, which include aircraft and spacecraft and the design of those. And so some of these some of this work would include rocket guidance in space flight, as well as building in the control of space stations. And so these courses would include thermo, aerodynamics, dynamics and structures, and controls. Next, we have biomedical engineering, which is our personal favorite. Biomedical engineering is the application of engineering to biology and medicine. And so this has a lot of different flavors, including bioinstrumentation and medical devices, biomedical imaging and optics, biomechanics, and biomaterials and tissue engineering. And so some of the courses that you would take as a biomedical engineering major would include organic chemistry, biology, biomaterials, and as BME is really broad, it would really depend on what specialization you'd want to go into. So for example, if you were interested in biomechanics, you would take more mechanical engineering type courses. If you were more interested in cellular manufacturing, you would take a lot more chemistry. Next, we have civil engineering, which is the engineering discipline that deals with the design and construction and maintenance of the physical and naturally built world, which pretty much just means designing highways and bridges, developing water distribution and wastewater collection systems, and is usually heavily involved in city planning. And so some of these courses would be fluids, hydraulics, structure design, and mechanics of materials. Next, we have computer engineering, which integrates computer science with electrical engineering to help develop new computer technologies, and will have the hardware background of an electrical engineer and the software background of a computer scientist. And so these courses you would take as a computer engineer would include data science, electronics, signal processing, and data structures. Lastly, we have material science and engineering. And so material science, as it implies, is the study of materials. And so it involves creating new materials and improving existing materials, including metals, ceramics, and polymers. And so some courses that would be relevant for a material science and engineering major would be thermodynamics, materials processing and manufacturing, and the properties of materials such as their electrical and optical properties. And so those are the main types of engineering. However, there are a lot of more specialized engineering types. And so those include environmental engineering, nuclear engineering, engineering mechanics, and petroleum engineering. And so there's really a lot out there that can be considered engineering, and a lot of different paths that you can take with an engineering degree, which we're going to talk a little bit about with our panelists. And so that kind of concludes the overview of the different types of engineering. And so now we'll get into our panel. And so I have, like I mentioned before, 5 BME grad students here to talk about their experiences as an engineering student and kind of why they are here today. And so if you guys want to just go through and give a quick introduction of you, your name, where you're from, and what undergrad major and institution you went to.
Hi, everyone. My name is Maribel Torres Velasquez. I am originally from Puerto Rico. That's where I was born and grew up. I did my undergrad in the University of Puerto Rico in Maya West, and I majored in electrical engineering.
Hi, everyone. My name is Ali. I'm originally from Houston, Texas, and I went to UT Austin and studied biomedical engineering.
Hi everyone, my name is Alana Stempian. I am originally from Buffalo, New York, and I went to Rochester Institute of Technology in Rochester, New York, and my undergraduate was in chemical engineering.
Hi, I'm Sarah Harper. I'm originally from Salt Lake City, Utah, and I did my undergrad in Albany, New York at Rensselaer Polytechnic Institute, where I did a dual major in biomedical and mechanical engineering.
Hi, I'm Leslie Arant. I'm from Sheboygan, Wisconsin originally, and I did my undergrad at Marquette University in Milwaukee, and I studied biomedical engineering with a focus on biomechanics.
Awesome. So thanks, everyone. We're very happy that you're all here today. And so to start off the panel, our first question is, how did you choose your undergrad major or decide between different types of engineering? And so within our panelists, we have varying different backgrounds. And so how did you decide which engineering you wanted to study? As well, what experiences in high school helped you make your decision to pursue an engineering degree?
So I guess I will start. While I was in high school, one thing I was for sure is that I liked science and math, and I think we all kind of gonna agree on that. But most of my family members were either teachers or something related with the medicine side. And I wasn't sure what I wanted to do. So I had this great opportunity to attend a engineering camp for high school students. And the whole purpose of the engineering camp was to expose us to what each engineering do, at least the classical ones, and the ones offered specifically at the University of Puerto Rico in Mayagüez. And during those time in the camp, I had the opportunity to just run small experiments. Like, for example, for electrical engineering, we got to build a robot. For mechanical engineering, we built a oven using aluminum paper and talking about like the material science behind it. So it was like really, really cool to do that and see kind of like what areas I kind of like it and what actually captured my attention. And I think that experience combined with my passion for math and science kind of made me decide to then pursue electrical engineering.
So yeah, in my personal experience in high school, we had this initiative called Project Lead the Way, which was basically like a STEM initiative that forced either engineering or like biosciences. So you like choose one or the other. I chose the biosciences because I originally was more interested in healthcare and wanted to be a doctor. So from that, I learned about different malignancies, how do they affect people, what's important about them. And it was from that class that I was introduced to like many classic biomedical engineering topics like tissue engineering and biomaterials. And so that kind of led me towards BME as a major. And that was further enhanced by, we also had HOSA, Health Occupational Students of America. I joined that club and like was part of the leadership there. And from that, we kind of like taught students a lot about these malignancies, and it kind of made me think about what's the best way to like impact these issues. And I personally found that at the research level, at the most fundamental level, is the best way to do so. And I found that through BME, you could have that sort of impact. So that's kind of what drove me to that major, and more specifically research eventually.
So my path to chemical engineering wasn't quite as formal, I would say. As probably most on this panel will agree, I enjoyed my math and science classes in high school, specifically chemistry. And my AP chemistry teacher was a chemical engineer by trade before he began teaching. So I liked him and I liked the class. So I kind of thought that chemical engineering would be a good pick. I tried to talk with other family members or friends of the family that were in different types of engineering, and I guess take the other approach and sort of rule out other types of engineering that didn't sound as interesting to me. And then I started visiting universities my junior year of high school and talking to department chairs and students and trying to understand what types of classes I would take as different engineering majors, and ultimately settled on chemical engineering.
So for me, I think I had a lot of similar experiences to everybody else, what you've all been saying. But for me, I've always grown up playing soccer and sports, and especially in high school, I got really into strength and conditioning and getting curious about physical therapy and why do we do certain injury prevention moves and why is form so important. And I got kind of questioning like the mechanics of movement type things. And I also got to go to a couple exploring engineering camps while I was still in high school, and I got to see a couple groups of grad students working with like motion capture and stuff, and looking at how people were moving. And I was like, I feel like that's right up the alley of what I want to do, and I want to be able to make devices that surgeons and clinicians and all kinds of doctors can use to help people, because I always thought I maybe wanted to be a doctor, but I'm squeamish. So I was like, I'm nerdy math and science. I can maybe design those tools for them to use to help people. So that's what led me to that. And as far as then specifically picking biomedical and mechanical, I wanted that overlap. And to me, at least, as far as I've seen in engineering so far, a lot of fields, especially biomedical, are like overlap very well with each other. There's a lot of common principles between the different disciplines of engineering that allow you to kind of combine them and try to get the best out of both sets of degrees, So, and that also, the last thing I wanted to say on that, it reminds me of I had a friend who rotated between mechanical and aeronautical and electrical for years up until she graduated, because they're so closely related that as far as coursework, if you don't know exactly what you want to do, when you get to college, it's okay. It's not the end of the world. You can make some changes and figure out what you want to do.
Yeah, so I definitely agree with that. I really liked math and science like everybody else in high school, especially physics. But I didn't really get much exposure to engineering in high school. And to be honest, I don't really think I really knew what it was. But I decided to pursue engineering kind of at the recommendation of some of my teachers and guidance counselors. And I knew I was also really interested in the medical field too. So that's kind of why I decided to pursue biomedical engineering. But even then, during my first year of college, I still really wasn't sure whether biomedical engineering was the right kind of major for me, just because I had a broad interest in a lot of the different engineering disciplines. But luckily, during my first year, we kind of had a class that exposed us to a lot of those different areas of engineering. And through a lot of hands-on labs and everything, I was able to kind of confirm that biomedical engineering specifically was the right major for me.
Great. Yeah, it sounds like with a lot of the responses, the availability of different immersive engineering camps really made a difference in our decision to pursue engineering. And so it's really exciting that that seems to be something that's growing and being prioritized and developing those. So yeah, so next I'd like to ask, what kind of career paths can you take with an engineering degree? And what opportunities are there in undergraduate to help you determine which path to take?
So specifically for my undergrad, I think my undergrad is a undergrad heavy in industry, in telling you once you finish your career, you're gonna go to industry. There is a little bit of research opportunities. So basically, when I started my undergrad, my first instinct was okay, I finished with my engineering degree, I'm gonna go to industry. And to do that, I will say that one of the experiences or a decision I made was to get involved in different professional associations, like the Society of Hispanic Professional Engineers, right? And they have this ability to prepare you to get internships. You can get internships in industry to kind of get exposed to the type of work that company does to see if it's a fit for you. And I think I did that. I actually had 2 internships with General Electric's appliances in Kentucky, and that made me exposed to maybe that kind of path, which is working for an industry. But then while I was doing that, you kind of experiences, as we all know, kind of show you what you like and what you don't. And I had this kind of feeling that I wanted more or something different. And in my case, I actually had this professor, Dr. Rodriguez, that he one day came screaming on the I was in a classroom, he came screaming my name, and I wasn't sure why, because I didn't know him. So I was like, well, Maribel, you don't know me, I know you. You have a good GPA. You're one of a few girls in electrical engineering. I want to show you what research is. I want you to get exposed to that. And the way I do that is helping you get actually an internship doing research. That for me was a shock. I didn't know that was a thing, even though, when you get to undergrad, people have this assumption that you need to know everything, but the reality is you don't. Experiences show you on the way. So he said you could get a research internship and see if performing research either in an industry or in an academic setting could be your future. So he helped me actually get an internship at University of Wisconsin-Madison. And I did a summer internship here and I really loved it. And that experience, he was the one that kind of like pushed me to do that. So when I went back home, I decided to then do undergrad research with one of the professors there. So I think I will say that the way of finding if you like more that kind of like industry job or that kind of research job is to expose yourself to those experiences. You're not going to know it until you try it. And a good way of finding those opportunities is either get involved with professional associations or finding a professor that could like mentor you.
I definitely agree with a lot of those points. The general idea that I think you should just try stuff. That's the best way to know if you like something. And for me, it was just researching like what opportunities you can get with what level of like expertise and what. So I found that with industry, you have a more defined role. You have a more like, you know what you should be doing and who you're working under, what the project is. There's like less room for, I'd say, creativity or like movement. Whereas with like research and other stuff, there's more creativity involved, generally, like individual creativity. So I would say the best way for me that I found to find what I wanted to do was to like research first and then go try stuff. So when I got to UT, one of the first things I did was I knew I liked research, like reading about research and like the general process. So I would reach out to undergraduate labs and see if they had openings, and then I would start in their labs. And that kind of like started the process for me of loving research and I love the creativity. I loved all the aspects of it. But for someone who is like industry, I think there's a lot of like carryover between traditional engineering degrees. So for example, my dad, who's a mechanical engineer, works in like a chemical engineering company, but the overlap is very great. Like, it's not that if you are a chemical engineer, you'll forever work in that field. You can always move around. The general like engineering principles don't like tie you to one discipline per se. So yeah, I would say just try things, do internships, do research, try a bit of everything, because undergrad is a great time to figure out what exactly you'd want to do. And yeah, just try stuff.
So as a chemical engineer, I kind of mentioned, chemical engineers generally go into industry and have kind of a type of job rather than a specific field. Any product that is made through chemical processing, a chemical engineer can work helping to design that. So that can be anywhere from toilet paper to nanomaterials. So I was lucky that my undergraduate actually required us to do internships. So I worked at 3 different companies and had 2 research internships, and they were all in completely different fields and different types of industry. And as you just heard, trying everything and finding out what you like and also what you don't like is probably the best way, getting that exposure. And I kind of stuck to chemical engineering classes through my undergraduate, and then in my last year with some of my free electives started to take biomedical engineering courses and completely fell in love with those, even though it was my senior year. So I knew I kind of wanted to start pursuing that direction, so I actually decided to work at a biotech company for a year before going on to graduate school to kind of help me transition across fields. So I think getting exposure to different fields, again, through internships, through coursework, through different organizations is really the best way to kind of learn about what you want to do after graduation.
Yeah, I guess I don't have too much more that can be said that hasn't already been said, but just I guess like from my perspective, you know, I from the get-go, I feel like I've had it in my sights to go into industry, and just the further I went along through undergrad, I got opportunities to do undergraduate research and in a couple different labs and at different universities over like summer projects and things, and so that helped me narrow my focus, like confirm kind of my interest in the certain area of biomedical because it's so broad, and kind of build connections. And like Maribel was saying, I was part of the Society of Women Engineers, so like that was a kind of professional connection that you could go to conferences and meet people and get exposed to things like that. But definitely being proactive about it is going to be your best bet. You know, like everybody's been saying, like undergraduate is exactly like the time for that. Whether you're doing an undergrad, a co-op, study abroad, research, you know, whatever. So all of those are very helpful.
So where I went to undergrad really also focused on preparing their students for getting jobs in industry. So that's kind of what I knew best, and I guess what I can still probably speak to the most, just because I've only been in grad school for like a little over a year now. So I guess I can kind of talk about some of the different paths in industry. There's like kind of more of the technical side of things where you can be like a, you know, product design engineer or like quality engineer or research and development engineer. But then on the other side of things, you also have engineering majors who go into like technical sales because they can provide kind of the technical knowledge that, you know, regular businessmen wouldn't always understand. And there's even opportunities to go into like the legal world and be a patent engineer. And those are engineers that kind of can use their technical expertise to write patents for new inventions. And so you'll probably hear this a lot, but an engineering degree really teaches you how to problem solve. And so that skill set can really come in handy in a lot of different roles.
Yeah, I'm really glad that you mentioned that, Leslie, because I think an engineering degree is definitely not going to pigeonhole or rabbit hole you into a certain role, and you can really identify your interests and, you know, tune your career path to whatever you truly want it to be with an engineering degree, because you have a powerful problem-solving toolkit along the way. So I think those were some really insightful responses, and hopefully that, you know, answered any questions that you may have about what an engineering career could look like. So next, we're going to transition a little bit into biomedical engineering in particular, because that is what we are all studying, and in particular into grad school as well. And so the goal of this next segment is to kind of give you an idea of what grad school could look like in BME. And as you'll notice pretty quickly, there's a lot of diversity in the type of work that you can do and the research that you can do. And so the goal is to kind of give you guys an idea of some of the research areas that are available within BME, to give a better picture of what a grad student's work would look like. And so to start, we'll just go around and give an elevator pitch of your research.
So I guess I would start for mine. As I said before, I have my electrical engineering background, which means I had a lot of classes in signal processing. So when I came here to UW-Madison, my research expertise focused in neuroengineering, specifically in neuroimaging, which is the processing of the images from the brain. And these images could come from X-rays, CT scans, MRI imaging. For the purpose of my specific thesis, I developed computational techniques and mathematical models to study and improve the diagnosis and follow-up treatment of neurological diseases. And I have worked a lot specifically with the disease of epilepsy.
Okay, so based on my undergraduate research, which was mainly in tissue engineering and mechanobiology, I pivoted here towards a more in vitro modeling project, where essentially what is occurring is we're trying to make models of ovarian cancer. And specifically, what I'm trying to do is look at the environment surrounding these cells and seeing what chemical and mechanical cues from its surroundings, known as the extracellular matrix, causes these cells to undergo phenotypic changes, which basically is characteristic changes of the cell, initiating the progression of cancer towards distal sites. And essentially, my role in this is to create these models which have accurate representation of this environment, and also accurate physical representations of like curvature, topography, and various other mechanical cues, which can, we hope, see if these cues cause these cells to progress into cancer cells. And from this modeling, we hope to manipulate these cues to hopefully better characterize cancer and maybe develop some medicine as a result of these models.
So my research now doesn't really have any follow-up to anything I did in undergraduate, which I think kind of reemphasizes the point we were making before, that an engineering degree doesn't kind of force you down one path. So I don't really do any chemical engineering now, but that general engineering background has definitely carried me into my research. So what I do now is I study heart cells, specifically the cells that are responsible for the beating of the heart, called cardiomyocytes. And I engineer and build platforms to culture these cells on. And so I'm designing specific properties of that platform that can mimic things that happen in the heart. And I then look at how those cells respond to those platforms in terms of their mechanics, so how they actually contract. And I can measure that, again, in response to changes, to model and understand heart function, specifically heart disease. So if things that are happening in the heart or biological changes, mechanical, chemical, whatever it may be, I can build like a tiny model of that and look at how those cells will respond. And that helps inform what's going on with disease progression. It can help clinicians understand how to diagnose and treat, and also inform what pathways we may want to target for developing treatments for heart disease.
Okay, so in my research, our lab really centers around this technology that we've developed to help us look at the forces and the loading that's going on inside your body while you're doing, any activity like running, jumping, walking. And basically our device is trying to fill this gap where traditionally it's been really hard to assess these types of loads because they're inside of your body, and to assess those traditionally, the most accurate way would be to be very invasive and like surgically implant something in your leg. And that's maybe not super feasible for everyone who's maybe just trying to go to the clinic for, like some tendonitis, runner's knee pain or something. And so specifically in my project, I'm trying to take our sensors that we've developed and transition them into a wearable form that we can ideally like put on an athlete and send them out to practice, or send it home with a patient, an outpatient clinic person, and get data back on their day-to-day life of how they're moving within their home and up the stairs and to the grocery store and whatever. And so a lot of what I specifically do is like design iteration and like verification of how this device is working, and trying to make this thing really repeatable, and just all of those like design aspects of improving this device. So yeah.
So my research is pretty similar to Sarah's. Our labs kind of do similar work. We're also looking at using those devices that she was talking about, but specifically to measure forces in ligaments is what I'm focusing on. So like if you've ever gotten an ACL tear playing sports, it's likely because like the force in your ACL exceeded some safe threshold and then got torn. And so there's really no tools that are currently available, like Sarah was talking about, to directly measure how much force is restrained by your ligaments. And so my research works on developing some of those tools, and we're using them in a variety of applications, including total knee replacement surgeries, or we're also looking into how your ligaments might change with disease, and specifically osteoarthritis is what I've been focusing on.
Great. So that was only a small subset of what biomedical engineering research in graduate school could look like, but I hope that gave you a good idea of all the different types of research that you could be involved in if you chose to pursue a graduate school in BME. And so we have one final question to kind of wrap up our panel. And so it is, what do you wish you knew as a high school student entering an engineering program?
That's a hard one. Many things, but I think the most important one is knowing that it's not a straight path and that there is no right and wrong answers. Everyone have their own journeys. Everyone finds what they want to do in their own way. So we should never like compare yourself to like, maybe if you have a friend that already knew that they wanted to do mechanical engineering because they were really passionate about engines, and you're like, well, I don't know what I want to do. That's okay. That's why undergrad is there. That's why you should just go explore the world and find what you want. And if you start as a mechanical engineer and then you suddenly decide that you want to build circuits, and halfway your undergrad you decide to change, that's okay. There's no problem with that, and you choose your own path, and there's no right and wrong. I would say that was really a struggle for me to come to a peace and say like, it's okay, Maribel, to like start as an electrical engineer, but now you want to do something the hell in the medical world, so you can use that background. And now in grad school, you can still do something kind of related to what you did before, but still in a different field, and that's okay.
I guess the thing I wish I had most going into college from high school is kind of like the foresight of like seeing like your friends change majors, go back into majors, and seeing how like you can go from BME to Mechie to Chemie and you'll still be fine in your career. It really is nothing. Like I've had friends go from engineering to the sciences to social sciences. Like there's a bevy of different things you can go into and out of, and in the end you'll be fine. So I guess I wish I had that foresight of seeing like my friends being able to like transition to different like even career paths, wanting to go from grad school to industry, and in the end you'll be perfectly fine as long as you have a general idea of what you want to do. I guess that would be the main thing that I would say to myself is sort of don't worry about it, just do your best at whatever you're passionate about and it'll work out.
Yeah, I think I would reflect a lot of the things I've already been said. On the one side, that whatever type of engineering or whatever it is you choose to do, you're not stuck into what you think the typical job in that field is, and so you're going to be able to explore. And so you don't have to get scared that you have to pick like exactly the right major to do exactly the job. There's definitely multiple avenues to that, but on the same side, to stay open to different experiences, classes, seminars, internships, whatever it may be, because I kind of hit a point where I thought, okay, I'm going to decide what I want and then I have to stick with that. And clearly that's not how it ended up. I hated biology in high school and I thought I was never going to do anything related to biology, and here I am. So just letting yourself be open to experiencing all different types of career paths and whatever interests you may have, and knowing that it will all work out in the end.
Yeah, I agree with all those points. They're all really good. And I guess the only thing that I can add onto that, and in addition to like being open to experiences, like really just take advantage of everything that you can, whether that's career fairs or like, you know, resume critiquing sessions and all kinds of things that are like right at your fingertips at most universities. I feel like use those while you're there. And personally, like, you know, what I've learned, I guess, in hindsight is the most important thing that I hear over and over again, and you probably will too, is like networking. You know, just like take time to make connections with whoever you meet, and because you never know where a job opportunity is going to come from, or research, or what, you know. So those can be more valuable than, you know, even though that's what everyone says, it I feel like is very true. So that's all I have, yeah, about that.
I would say my advice would be that it's okay to go to college to study engineering without having had any exposure to it before. I know I was really intimidated on like the first day of classes. I think when my professors like asked the class if, you know, raise your hand if you had participated in engineering activities in high school or did engineering camp or whatever, and like a bunch of people raised my hands. And like I said, I didn't even really know what engineering was at that point. And so I kind of felt like unprepared and like maybe I didn't belong there. But I would just say that don't let that that kind of stuff scare you away from engineering. Like, don't be intimidated by it. As long as you like it and you want to be there and you try your best in your classes, you deserve to be there just as much as everyone else does.
I think I have one more thing, if I could say it. It just made me think, when I heard Sarah talking about networking, it made me remind that it is good to find a mentor, maybe a professor that you really like, or a friend that is older than you at the end of the career, and ask the hard questions. You know, there are no non-important questions or a question that's not important. If you have, there's something you don't know, there's a goal that you have, but you don't know how to achieve it, just ask the questions. I think that applies in every aspect of your life, either if you're in industry working or you're just taking calculus class, it applies. Just don't be afraid of asking questions.
Yeah, that's actually what I was about to say as well, Maribel. My biggest regret, I think, looking back on my undergrad, is that I didn't connect with my professors, though I really wanted to, and I didn't utilize office hours. And I know that in general, office hours, I feel like, are underutilized. I would, struggle through homeworks, but I would be too afraid to go in and talk to my professors. But after, being kind of on the other side and having a graduate mentor that's an advisor or a professor that I work with a lot, and those times that I did talk to my professors in undergrad, I realized that they really, really enjoyed talking to students and that we weren't a burden on them, which is maybe what I felt sometimes. And I really looked up to them, but I was afraid to really connect with them. And so they are there to support you, to help your growth in learning as students, but also as individuals. And you can really learn a lot from developing a mentorship with a faculty or a professor, and those relationships have been extremely rewarding for me. And so that would be another thing that I would say, even if you're a freshman and you feel like you maybe don't know what you're doing, talk to your professors. They want to talk to you. So yeah, I guess if there are no other final comments that anyone else has, I'd like to thank all of our panelists for taking the time to answer these questions. I really hope that we could give you some insight on engineering and all the different various ways that engineering can look like. I'd like to thank you for listening to our panel today. And yeah, I hope you enjoy the remainder of the Wisconsin Science Festival. Again, we're the Biomedical Engineering Graduate Student Association. So.